All right, so one of the key topics that Rick brought up was the problem of finding skilled workers and how this impacts skilled workers. It's going to be a theme today. So, David, let's start with you. One of the questions that we have is that the skilled workers are in short supply in Massachusetts. Automation, robotics can help or hurt. Let's talk a little bit about that. How does it help the system of critical shortage of these workers?
So that's far and away the most calls that we get come from customers that just aren't able to get enough skilled labor or want to expand and need to prove to their customer that they have the capability to rapidly expand and adapt to the market. So one customer just recently, they had a contract that was either going to go to them or was going to go to potentially a plant in Texas or in China. So they had to show that they could ramp up to demand for their big aerospace customer. A team of 4 machinists there was the core bottleneck, and we brought in a collaborative robot for them. They were able to boost productivity of that team 40%, reduce defect rate 3-fold, and that team got a 12% boost in wages as a result of that, and they won the contract.
And so when you look at the impact on workers, I mean, how does that impact negatively? I mean, does it impact negatively, first of all?
We had an incident recently. We were called in to evaluate whether robots would be suitable, and after the meeting, the guy who called us in, his car got scratched up a little bit. At that plant now, though, there are robots in with the team. The existing team on the production line is managing the robots, so it's like their new fun tool that they get. So that completely changed. The difference was when it changed from the perception of what a robot is to getting a robot in there for the folks to use and seeing the difference it can make.
Martha, Rick had said that this is the #1 issue, skilled workers for the next century. And I've been doing this for 3 years, and you've been living this for far longer. And I know this has been an issue that's been building. How do you see technology helping you address that need?
It's interesting. So there's multiple layers on this, and not to be the skunk at the garden party, but we are primarily a technology company. And when we think about that shortage, it really is around the computer scientists, the data scientists. Very often it's the integration of hardware and software. And so it's actually placing a little more demand on that front. I think the great news for anybody in the area is these are really vital, really long-lasting jobs, but we have all got to do a better job of producing more of that talent set. It's challenging, and so part of that means, starting really, really early, reaching out in STEM programs to talk about coding, to get portions of the population that might not be seeing a career in these fields to understand that it is available. Engineering has been a shortage for a long, long time. We spent a lot of time having an impact on that. Massachusetts is a great place for getting really, really skilled engineers. We still don't have enough of them.
Where do you think the breakdown is, or where it began? I mean, obviously, as you said, the STEM fields coming up through school not being populated by students interested enough. Have the school systems been doing enough, or have industries just changed so fast that it's gotten ahead?
I think it's a combination. I really appreciated the quote we heard from Rick early on, that the answer is education. It is education. I think very often we find we're dealing with programs that have been built around the current context of the industry versus that overused phrase of developing a curriculum where you're skating to where the puck is going. And so I think all of us could be doing a better job at saying, not just what are the new things we should be training people in, but what does the curriculum now look like? For example, a doctor. What does the curriculum look like for somebody who's in the design realm? We're very often thinking about we need more data scientists. How do we start to get more of that acumen built into some of the core curriculum? And that's one of the things we're focused on.
So Peter, this is obviously, there's no simple solution to this, and it's a long-term solution, but you need people right now. What do you do to bridge that gap between what the job requires and what people are bringing to the table?
Well, there's been an interesting movement that's just started, and it'll be curious to see if the people in this room start to talk to schools and education about it. And that is, schools and education up till now have guessed where the talent needs to be. As you said, skating to the puck. And when a corporation is asked by a STEM group or a high school or a community college, they're asked to help the community college or the school. What's going to start to happen, I'll see more and more, and the town of Marlborough is very advanced in this right now, they'll start doing a demand-driven model, where they'll say to the corporations, what do you need? And start talking about what the company needs rather than what the school needs. So I think there's going to be a slight switch in how education is driven. I think it's going to be driven a lot more from the corporate level to the educational system, instead of right now where schools are trying to guess 5 years ahead. Just very quickly, Electric Boat in Connecticut had this dilemma and have handled it exceptionally well. So if anyone wants an interesting study, Google Electric Boat and how they're going to meet the contracts that they just received, because they have to hire thousands of people in a very short period of time.
Is it more, I mean, if you could draw an analogy, is it like driving the square peg into a round hole, or is there really a method to the madness here in finding the solution to a skilled workforce?
It's a hexagonal peg being put into a round hole. It's a work in process. I mean, we've had this system for an awful long time, but the timing is beautiful, because with unemployment at the level that it's at, and technology kind of crossing that point of theoretical into applied, you're going to see this advance very quickly. And I think it's going to be a lot smoother in the years to come. But again, I think the corporations have to get involved, not thinking of working with schools and education as a community service, but thinking of schools and education as a place that they can demand what they need.
It's a process. So as we take a look at how robotics, AI affects us on a daily basis, Martha, your company provides the eyes and ears on a lot of things we use every day. How is that impacting what we're doing now? And is it going to be in your face, or are we going to kind of creep into everyday life deeper as we go down the road?
Yeah, the honest answer is I don't know. But when we look forward, I can kind of give you a perspective on what we see. So we're in the business of sensors. Sensors have been in machinery for a long time. For most of the time, they've been there to actually provide control of equipment and control of machines. If we look at what's driven their proliferation in the past 20 years, it's been the need for greater safety, better energy efficiency, security, things that we're all familiar with and you see in your everyday life. They've had some economic impact. The cost of a vehicle today as a portion of discretionary income is way up from where it used to be 25 years ago because of those mandates. Let's look forward though. We make a big distinction between automation and autonomy, and I think we're really talking about autonomy. And the Nutonomy-driven installation in the seaport notwithstanding, it's one thing to take robot cars in a highly mapped, highly contained, highly controlled environment. It's another to say, I'm going to go up to Vermont and ski, and my autonomous vehicle is going to take me there. We're a ways from that point in time. We're working on sensors that actually help enable that functionality. We're probably going to see that kind of, we call level 5 functionality in the 7, 8-year time horizon, maybe a few installations before that in years 5. But what is it going to mean around disruption? So you're potentially talking about an industry that is very different than the one you see today. The real question is, will we continue to have private car ownership? If we don't have private car ownership, what's changed? Now we're talking about a world where this becomes an asset utilization question. This becomes, you're no longer selling private cars, you're calling up your favorite fleet manager. And so that is a lot of change. It's a lot of new jobs. It's a lot of displacement. And so I really think that's where we've got to take the conversation. What is the displacement going to be? And how do we think about the human challenge of dealing with that? It's manageable, and I just laid out a time horizon where we ought to be able to adapt. I mean, that's not immediate and it's not overnight. But the level of change potentially is pretty great.
You know, you talk about these things, and when you just generally think about, I have a tendency that I feel like my head's going to explode sometimes. But I mean, do you as a CEO running one of these companies, do you ever look at it and say, I got to get away from this? It's overwhelming. Do you ever have that sense?
You know, honestly, it's invigorating. It's exciting, and so part of that
Robotics.
is how do you respond to change, and how do you get a large organization to respond to change? In this kind of environment where there are so many potentially disruptive forces, today we're talking about artificial intelligence, we're talking about automation, we're talking about robots. Think about things like blockchain. Think about things like the electrification of a lot of equipment. There is lots of change going on. The way I think about that is you're not going to be able to take a single vision of the future and decide that's exactly what it is. We have to be adaptable. So we have to place smaller bets. We have to come together. Sometimes we're competing, sometimes we're collaborating, and you see what it takes and you move towards it. But managing the level of change that we're talking about is very different, I think, than both the pace and the amount of proliferation we've seen in the past.
All right, David, let's talk a little bit about technology forever has advanced. Do you see robotics and AI as leading that advancement, or is that just part of the whole process of an economic evolution?
I'd say, in looking back, it's part of the whole process, in that you could consider something like Microsoft Office that you could say took a lot of jobs, or freed people up to do more important things. So right now we're seeing the convergence of AI and robotics, from sensors to some of the autonomy. And I must say, autonomy within a factory or so is much easier than on the roads of Vermont. So that's moving at a pretty good clip right now. Robots that can navigate a facility, but robots, part of the autonomy also lets a robot work closely with people. So you can have robots that are not just taking the place of people on some completely automated line, but working closely with people, right beside people, sort of as a productivity boost tool. So you could think of it as Microsoft Office, or a power drill or something that added some autonomy. Now you can have robots that are sharing in some of the very localized task decision making, whether that's manufacturing or, like we saw at the Barrett warehouses, getting to the right spot at the right time. So I think this is a big change point right now, just that the AI and sensing is coming together. The time horizon I would put is just over the next 7 or 8 years, there will be a big change in certain industries. So that points back to it. It's time to start planning for some of the displacement that could come. In the Boston Consulting Group estimated that by 2025 we'll have about 4 times as many robots in the U.S. as we have now in commercial settings. That's a big change. But it does mean that we could start planning now for training people to adapt to that scenario. And you mentioned displacement earlier. In Acemoglu and Restrepo's most recent study out of MIT and BU, is that even in that scenario where we have that many more robots in the U.S. that soon, within 10 years, the effect on U.S. employment, if we don't do anything, will be about a 1% change in unemployment, which is big. But if we plan for it and handle displacement, then that can be offset.
Peter, when you look at the chicken or egg scenario when it comes to advancements in AI and the economic evolution, which side's wagging the dog?
The company's need to be competitive is going to drive what technology they use. And robotics in particular, the personification of a robot is probably the biggest obstacle. You saw the video earlier today. Anyone in this room that's over 55 remembers 13-column accounting paper. And then, I went to work for a large company. It started with 13-column paper. Next thing you know, there was something called Symphony, and then there was something called Lotus, and then something that ended up being what we use today in Excel. It evolves. It evolves based on our own personal need. And I think if you can get by this idea that a robot replaces somebody and get more into the fact that it enhances your value proposition of everybody. It will be driven faster. So frankly, people grab onto technology that they feel will advance them and help them, and they push away technology that they feel is a threat. So it really comes down to how friendly can we make technology look, I think.
Or creating a beast, right?
Right, or yeah, yeah. Like David said, somebody scratches the car because they, at that point, felt it was a threat. 3 weeks later, they're arguing over who gets to use the robot to make themselves look good.
Martha, I mean, this is a huge question, but I mean, are we creating our own downfall as a society? Or is this all good? Is everything AI, everything robotics good in the world?
Look, big disclaimer, I am an optimist by nature. So it's really hard for me to see it as, the dark side. There are often unintended consequences, to any change. And so I think our challenge is to think through the overall impacts. But overwhelmingly, technology can be a huge improver in the quality of life and in the advancement, of us, the species, and the protection of our planet. So lots and lots of capability. It's just really important to think through the ramifications of that.
All right, so this brings up a good point. That a lot of people seem to be afraid of the fact that they work either alongside a robot because they believe that ultimately it will take the person's job. So David, collaborative robotics, that's, Rick talked about it, you've worked in it, an expert in it. Yes. What sort of impact does that have on your workers? I mean, when that is introduced, I mean, how do you introduce that into the workforce, the factory floor?
So our primary clients are manufacturers. So the collaborative robotics, when a company adopts it, since the robot's working very closely with a person or a team of people, the people feel much more responsible. Like it's their tool, it's their robot, and they get control over it. And a lot of what we're bringing our technology in the AI is to make that robot easy enough to train to do a task that you don't need, PhD engineers from Massachusetts to fly in and program your robot. That the team on the ground on the production line can get the robot to do what they want for themselves. So that's a big change. One thing that does for a lot of those, say, manufacturers in New England that are small and medium-sized manufacturers, they don't have their own team of roboticists or technicians. So it lets them much more easily deploy robotics, boost productivity, and not have to worry about if you have a robot that can adapt to its environment more, then you don't have to go back and reprogram it or handle it when it's broken down. So one example so we have one aerospace customer here who, when we did a work assessment walkthrough, they had skilled technicians that were spending about 30% of their time just fetching parts and getting them and making sure they were suitable, ready for the machining that they needed. By just automating that, rather tedious task. And it takes a lot of smarts for the robot, but it's a basic thing for a person. That boosted their productivity on that part of the plant by 30%. So again, it let them get this contract wins.
Can I just add
Sure.
to that a little bit? The other thing about human nature is when all of us do a job, we want to do it really well. And there are some things that happen in a factory, Peter can tell you a lot more about it, that are really hard for people to do, and they don't do it well. And so in our business, and I know you're really involved in this, quality is hugely important. And so for many, many years, our inspections were manual, our inspections were visual, and they were hard, and they were filled with defects, and it's not because people weren't doing their best. And so by automating some of that, we actually improved quality levels, got more demand in the marketplace, and added more jobs. And so bringing those proof points home is really important.
Can I give an example of that? It's funny, and sensors in particular have helped tremendously in optics, the advancements in optics. But imagine this is a great example, it's a real example. Imagine a bone staple. So it's a staple that allows you to put a bone together that's been broken, and it's tiny. And it has to be perfect. And it has to make sure it's perfect, because when the doctor gets it within a kit, he's going to put it in, he's not going to inspect it, he can't inspect it. And that bone staple has 14 different measurements that have to be measured. And it's this big, it's the size of a regular staple. Imagine a person manually checking all 14 points. With an optic reader now, they can literally throw down 20 or 30 of these staples onto a screen. And up on the screen, the operator looks up on the screen, and it is checking 14 dimensions of 20 different products at once and marking the ones that are bad red. And they can even go down further and mark what part of it was off so they can see what in the process was wrong. That job's a horrible job if you had to do it manually. It enhances the value of the person who's doing that job, improves the quality of the product, improves the quality of the process. So it's just a great example of what we're talking about.
So generally speaking, when you talk about your robotic workforce and your human workforce, there's a dynamic that goes on with human workforces, and you describe it as, I got a good crew, or this one's a troublemaker, or whatever. But when you introduce this element of robotics to the factory, how does that dynamic change? Because you obviously are reassigning humans to different jobs. I'm just interested in the psychology of a workforce and how it changes with these automated robotics roaming the floor.
And I think you saw a little bit of that. You saw a little bit of that in the Barrett video. That you had people are still working with each other. They're still in close proximity, but now they've adopted this robot, and they've even assigned it a bit of a personality with the hat and one with the bells.
Right.
So we find for people that's actually the interaction continues as a team. The robots don't go into the lunchroom, and they aren't part of the social scene that way, but they're out there as helpers, right? So we find that by that doesn't change. Maybe people get freed up a little bit to interact it because they're doing less dangerous, less tedious tasks. And certainly the inspection is one that we've seen that at one place people because the defects the tolerance for the defects had changed from the customer. So they gave everybody microscopes. Everybody was heads down on a microscope looking for little defects. By automating some of the material handling and inspection that way, people are doing their job, but they're not bent over microscopes all day. We're finding that also the people do get a sense that robots are included as part of the team, but I don't think it doesn't take away from the people-to-people bonding on that.
Any other thoughts from anybody on the psychology of a workforce?
Yeah, this is amateur psychology on my part. Inside of a factory, or even inside of a test lab, you have a workforce that's very comfortable with machinery. And we've had programs for years, they're called My Machine, because there is that relationship. You're absolutely right. I think the pudding will be, what about when we're in a retail environment? What about when we're in a restaurant? Because that's where we're all really used to human interaction. And so you think about that. What will our psychologists of the future look like? What will they have to be skilled in to allow us to make those changes in a really functional way?
It's a huge area of study right now relative to form function, because we think of robots as this humanoid-looking item. And people in Carnegie Mellon in particular, I got a chance to go out to Google last year with some people to talk about what AI would impact. And there were some people from Carnegie Mellon doing studies about what form you should take in that AI, because it dramatically changes how well people adopt it. And right down to, do you put a face on the robot if it has a scenario? You saw in your Barrett picture, they put a Santa Claus hat on there. Right. Do you personify it in some instances? In other instances, you take that away, you turn it into a machine that has a different dynamic. So I think there's going to be a whole study of when you use, what form factor you use.
All right. I have a quote here, and I want to get it right. So Peter, Bill Gates said this: the first rule of any technology used in a business is that automation applied to an efficient operation will magnify the efficiency. Likewise, the second is that automation applied to an inefficient operation will magnify the inefficiency. Do you buy that?
If you only knew how silly it is for me to comment on Bill Gates, you could just ask my kids. But I think the biggest factor in that statement will be how people are arranged in the first place. Companies are people. Robots are additive. And so it does come back to you have to have an efficient operation. Now here's the catch in that I would say it's slightly misleading. In Massachusetts, we have some great companies. MathWorks is a good example. MathWorks can help you analyze the data to know how to put in robotics, even if you're currently inefficient. Universal Robotics makes robots that do just what it says, universal robotics, where you can apply a robot that has such a universal application to it. You can get immediate, I've seen people have 3-month paybacks on the machine. So there are opportunities for people, even people out there who want to say, well, we're not ready for a robot. It's no excuse. There's an opportunity to take a look at it. So in one case, I think he's right in that if your enterprise isn't in shape, it's very hard to make any progress on new development. But there are people that can help you understand where robotics fit in, no matter how efficient you currently are.
For existing companies that are considering automation, just as part of the steps of considering the automation and seeing where it would fit best, they take a close look at their current process and operation. So we found many cases where maybe they'll adopt a little bit of automation, but as a part of that process, just the manual workflow at the site and then the management controls change tremendously.
We see automation, AI, robotics in a lot of industries, the auto industries specifically right now. Martha, what industries in the next 10 to 20 years are going to be most susceptible to these big changes?
Yeah, I think, I can articulate some areas where I'm pretty cognizant of the changes that potentially can happen. I think I would start by using another Bill Gates quote, and I'm in the same camp that you are, Peter. But one of the things he said was that technology almost always takes longer than everybody thinks it will. So autonomous, I think, is a great example, but it is much more ubiquitous at the end of the day. And so that's what I think about to answer your question. How ubiquitous and what kind of change? I mentioned the automotive business before. If you take the driver out of the car, the trade-off between owning and renting is hugely different. Now, if you're no longer a car company who's selling to private cars, but you're running a fleet, you can do all of your recharging for your car overnight. And now you might see a very quick changeover from gasoline cars today to electric cars in the future. Those things could happen quickly once you jump over the chasm. And I think they're going to be pretty profound. So will you still have dealerships? Why would you need those? Would you still have to have personal insurance on your car? Why would you need that? And so the ripple effect could be pretty profound, and that's one potential case that I'm pretty familiar with.